it's important for everyone to understand the design process. And what we want to do mostly, in this lecture at least, is talk about quality. How can we help quality improve early on in the design stages? Because just like everything else, quality is determined by what you decide up in the design stages. It can't be brought in at the end. So what do you think of when you think of design? Do you think of a scientist in laboratory? Or do you think of an engineer working on a computer, creating plans and drawings? Those are all design activities. And anytime someone is working on developing something new, or even doing some kind of improvement, or developing a system or a process or an environment, design comes into play. It's that series of decisions that people make and to plan out and make something that's going to be new. Now, design affects the end result of the product, obviously. Those decisions are what determine how a product is going to perform, whether it's how much the product is going to cost, or how much it helps a patient, or how long it takes to develop. Those are all determined by the decisions made in the design process. So let me introduce you to the rule of tens. In the design, as it goes out over time, you start with a concept, and then you get into detailed design, and then into things like prototypes, and then into even production at the end. This is the general flow of things through the design process, and there's little differences, but this is the basic flow over time. If we chart the cost of changes at each point along this design process, we might find that to make a change here in the concept stage might be $1, let's say. If we got to the detailed stage and found that same problem and tried to make that change, it would actually cost us much more to fix. It would probably cost us $10. And if we didn't find it until the prototype stage, it would likely cost us much more, $100. And you can see that at the production stage, that would be a terrible place to find this. It might be $1,000. So over time, as the design progresses, there's this rule of tens. Things get much more expensive to change and fix. So if you're trying to create a high quality a medical device or a pharmaceutical product or anything, where would you want to make these changes? You'd obviously want to make them here, where it's inexpensive. At the same time, if we chart the ability to implement the changes, that diminishes over time. Sometimes, even if you want to make a change, you can't out here in production. It's just too late. Things have gone too far. But here in the concept stage, virtually anything is possible. So that's important as well. Move everything up here early on in the design stage. So how much does quality impact a product? If we're going to design it, we have to make sure that we know what impact this is going to have. So I sometimes think of this like an iceberg. I'm going to draw the water. And the part of the iceberg that we can see, these are the types of costs and problems that are readily apparent in a company when there's quality problems. Things like rework, scrap, compliance issues, warranty claims, those kind of things. That usually makes up about 5 to 15% of a company's revenues. So if a company was a $100 million company, a typical company would spend $5 to $15 million addressing these kind of things. But this is just the tip of the iceberg. Underneath this iceberg, under the water, is a much larger problem. There's lost customer loyalty. There's excess inventory. There's the cost of engineering change orders. There's extra equipment. There's extra headcount. And we can go on. This is usually 15 to 25% of a company's revenues. That's huge. So altogether, this can be up to 40% of a typical company's revenue. That's huge. The only way to fix this is in design. You can't fix this after the fact. So let's talk a little bit more about how quality gets into the design stages. I often do this thought experiment with people to help them understand what quality is. It's important you know what quality is. If you can't define it, it's not likely you're going to be able to design for it. So let me draw something about any design that's important. This is some critical characteristic. It could be a dimension. It could be a performance aspect of this thing. And along this scale, in the design, you find out what is ideal. It's usually by working with customers to know what is the ideal target that you should be trying to hit on this characteristic. It might be how much of a certain chemical in the product, or it might be a dimension, or it might be the time it takes to complete something. But that's the critical ideal, and it's always driven by the customer. I'll put them here in the parentheses so we can remember that. But the reality is we can't always hit that exactly. And so we usually have some type of lower allowable limit and an upper allowable limit. This is the designer saying, hey, if we can't get the target, well, make sure you don't go any farther than that. So this is very typical. This is what designers do. They create these specifications based on what the customer needs in order to have a good experience and for the product or the service to be reliable. So let's imagine 4 different parts. This is going to be fun. So imagine one of them comes in really close to the target here. That's almost perfect. One of them ends up right here just inside the spec limit. Another one ends up just right outside. I mean, these two are just right on the edge. And then a fourth one is way out here, way outside of spec. So if you look at those 4 parts, let's number them. 1, 2, 3, and 4. Ask yourself, which of these 4 parts would you want in your product? If you were the customer, which one would you want? It's obvious, right? That's the one. Everybody always picks that one, and that's the right answer. This is the one, of course, it's right by where the customer would like things. Another easy question. Which one has the poorest quality? Yeah, it's this one. Nobody wants that part. It's way outside of spec. It's obvious that this is not a good part to have. But what about parts 2 and 3? This part number 3 is just barely inside the spec. And part number 2 is just barely outside. If you're a customer, which one of those do you want? Or if we can measure how the product performs, would it perform better with part 3 or with part 2? Or if it's a chemical, if it's amount 3 or amount 2? And really what happens, let's look a little further. This is kind of like football. And a lot of people think that quality behaves like this. If we're outside of the specs, I'm going to draw a new dimension here. This is the cost of quality, or maybe the cost of poor quality. But if we're outside the spec, we're going to incur a cost. We have to scrap the parts, we have to do a warranty claim or something. But then as soon as we cross this boundary, that cost disappears. We're good. Oh, and then when we hit this other side of the spec, we're back up to a cost again. So it's like football goalposts. If you kick the field goal and it hits the upright and bounces in, you get 3 points. If it goes right down the middle, you still just get 3 points. But if you miss, 0 points. That's the traditional view of quality. And we can write that out, and this is what most people would say quality is. Quality is equal to compliance with specifications. Now, unfortunately, this is not based in reality. This is what actually happens. I'll draw this one in green. Anytime a part misses the target, even by a little bit, it starts to incur costs. So the best we can do is be right on target. And that'll be the lowest cost we can have. But as we miss the target, a slight cost is increased. It might be due to a little bit extra processing that has to happen, or a little bit different handling, but it increases just a little bit. And as we get farther away from that from that target, the cost goes up and up exponentially. This is what happens in reality, this cost. And so you can see that even when we're inside the specification, the cost goes up a little bit. And when we're outside the specification, it doesn't just stop at this flat, it would keep going up. So look at parts numbers 2 and 3. There's the performance or the cost of part 3, and there it is for cost number 2. They're just slightly different. And if we push this to the limit, they're really no different at all. And so the critical thing to understand about quality is that complying with specifications does not give you quality. It's arbitrary. So we're going to cross this out. This is not a good operational definition for quality, especially if we're trying to design something. A better definition what do you think? How about this? On target with minimal variation. That describes quality. Now, let's talk about this through a real example. Back in the 80s, Ford and Mazda were working together on a joint venture. They were producing the same transmission for their cars. Ford would put this transmission into their Probe vehicles, and Mazda was putting it into the MX-6. This transmission was based off of the same engineering drawings, the same specifications. Everything was the same. But the experience between Ford and Mazda was very different. Ford started to have a lot of warranty claims and warranty returns on their transmissions. And Mazda was having very few. And so Mazda was making money on this transmission, and Ford was actually having this cost money, and it was hurting their business. This was very puzzling to Ford because over the previous years, they had set up a very detailed and strict quality management system. And what they had said was that quality equals compliance with specifications. They had said, we're not going to let anything leave this plant unless it meets the specification. It has to be in the goalposts. And they had inspectors at every station making sure that nothing advanced through the process or nothing left the plant unless it met specifications. And yet they were having this business experience that was not good. They were losing money on this transmission. So they had to find out what was going on. They got several of the Mazda-produced transmissions, and they got several of their Ford-produced transmissions, and they started to compare them. They tested them for vibration, which is an important characteristic of a transmission. They put the Mazda transmission on the vibration test equipment, and they started the test, and they thought the equipment was broken because the vibration was so small. Wow, they checked it. They had somebody come in, check the equipment. No, it was all okay. They redid the test, and sure enough, the vibration was that low for the Mazda transmission. They also started to tear the transmissions apart and measure each individual part and all the critical characteristics. And this is what they found. Ford was indeed, I'm going to do Ford's in red here. They were doing just what their policy said. They found some of their parts here, some of them here. They found some of their parts all through the specification. They found nothing outside, but everything was within. And if I may draw what everything looked like, it ended up looking like this kind of bread loaf inside the specification there. There was just as much chance of having a part here at the edge as there was in the middle. So they thought they were doing pretty good. Hey, our quality system's working. Mazda, on the other hand, when Ford measured the Mazda parts, they went like this. There were very few near the edges, and as they got towards the middle, all the parts started to look like they were near the target. Now, Ford was immediately started to see what the problem was. If you combine the number of parts with the cost, the real true cost, and I'm going to draw this true cost. I'm going to make sure we're seeing that. I'll do it in a different color here. This is the actual, in reality, cost of what's going on. You can see that Ford's parts in red here, there's a lot of parts out here at this high cost area, and a lot of parts out here at this high cost area. And they were seeing that in warranty returns and poor performance of their transmissions and lost customer loyalty. Mazda, on the other hand, was operating in this area where there's very little cost. They had higher customer satisfaction, higher performance, less warranty returns, and they were doing better as a business. And what Ford found was just like we've talked about. Quality works when you do it on target with minimal variation. That changed everything for Ford. Instead of having compliance with specifications be their policy, they now changed their policy to on target with minimal variation. And you can see the change that's happened in Ford over the years since. This is critical for design. When you know this about what quality is, you can now approach design in a way that you're going to make sure that parts come in on target with minimal variation. And you're going to stay away from any type of design that just says, hey, let's just get them in spec. So you might be wondering how this applies to your product, whether it's a manufacturing process, or whether it's a medical device, or a pharmaceutical, or blood and biologics product. This applies to all those domains. We've talked about the Ford example. Obviously, that's a product. But even if this is a pharmaceutical product, like a drug or a chemical, there are targets that you have to meet. There have to be certain chemical compositions in these products and certain specifications that have to be met. And if you're not meeting those, not only are you falling out of compliance, but there's going to be an impact on patients and customers and the way that the product performs. And of course, remember that iceberg, all of this cost is going to start to be incurred, even when it's inside of the specifications. And so the companies that do best, regardless of whether it's a pharmaceutical company or a medical device company or a car company, they work to have all their products and their services be on target with minimal variation. So what's next? Well, this is just the start. Once we know, now that we know what quality is and how to define it, now in the design stages we can bring tools and methodologies to bear in order to bring a quality product to market right out of the chute. In future sessions, we'll talk about how to turn this into actual tools and methodologies for designing products and services that have quality.